I'm Paul Bosserman. I work for Jimmy Shine's workshop, and today we're working on a 1961 Thunderbird. Belongs to Randy Kunkel, and we're going to fill in this cowl panel. This is originally the vent that supplies fresh air and all inside of the car, but we don't need it now because we have a new air conditioning system that will take its place. So the cowl vents are, it's kind of like a louver, and it's very hard to paint, sand, finish. So we're going to cut that out and replace it with a new panel. So we'll demonstrate how to do that, and we'll cut, fit, weld in, go back and finish hammering it to flatten it, make it straight again, and it'll be a nice new panel. So using a abrasive cutoff wheel, cut out the old sectional louvers, if we want to call it that, and cutting with, there's different ways of cutting, but cutting with a saw or abrasive cutoff wheel, there's always burrs left, which we want to remove because this thin metal often gets burned because of the heat, which is, when it burns, it's oxide, which can contaminate our welds. Plus, we want this edge to be really smooth for when we scribe our new piece to put in. So I will take a file and clean this edge up. The file actually, it's pretty simple, but it takes that off without creating any more oxidation. So now we'll clean this edge up with a this is a mill file, so it's a fairly smooth file, and it'll leave a nice smooth edge. So now I've prepared my new piece of sheet metal by spraying it with some layout fluid. This will help me see my scribe marks after we scribe it in the hole. So I'll put it in the hole and I'll add some clamps around. I want it fitting as tight as possible so we can make the most accurate cut. The tighter the fit we have, the easier it is to weld. It requires less filler metal, and it'll create less warpage as well. So all our cuts need to be very accurate. Make sure that comes up to the right arc still. So now I'll take a sharp scribe and scribe it as tight as I can in that corner. So you have to angle your scribe a little bit to get that mark. And that's what we will cut it on. Now you can see we have a scribed line all the way around. It's very, very accurate. If we can cut as close as we can to that line, then it'll be almost a perfect fit. And after we put it back in there, we'll take and tack it a few spots, and we'll hammer it together, and it actually can peen the metal at that gap and make the gap even closer. What it does is it squeezes the metal so that actually they will get closer together. Which just helps our weld that much more. I always thought welding was about 10% welding technique and 90% fit and preparation. And as you can see, I've also took, after I filed it, I even went back and there was some more paint residue. So I took a DA sander and cleaned more paint residue off. And even this, after we cut it out, I'll take and clean that layout fluid back off because that can also contaminate our weld. So now we have our new piece that we're using as our filler panel. And I have a wide edge around my scribe line. So I'm gonna cut it out with a pair of snips. And the reason I use snips, the snips I can get extremely close to that line. It's probably the most accurate way to cut a piece of sheet metal. The vertical bandsaw works well but you wind up with some burrs and it can grab and tear. The one nice thing about vertical bandsaw is it doesn't try to warp the metal as much. The snips actually will leave a little bit of a wave in the edge. A lot of times we can correct that with a hammer and dolly before we weld it in. But the 10 snips to me, that's my favorite. It's fast and easy and clean. I don't have to deburr it much when I'm finished. But when we start, this is too much to cut to do an accurate cut. So I will make a pre-cut and get it within 1/8 to 3/16 of an inch of my final line. So first I will cut and kind of help it along to bend it as you go. It makes the cutting easier. So now I have about 3/16 of an inch. Now I can come back and actually cut really close to that line. And that's where prepping beforehand with a file, I have a fairly straight cut on my other piece. So now with the snips, I can cut it extremely close. And I'll tell you about in the end, but when I make the final welds, it really helps prevent warpage by having these cuts as straight as you can and close as you can, because the fit's so tight that you don't have a lot of filler metal going in. Because you think about it, the wider the gap, the more filler metal, that's more that it can contract. The tighter the fit, there's less for it to contract. And that really makes a difference on doing finished sheet metal. So now I'll go around the rest of the piece and finish up. So I now have my new panel cut out, and I have fit it really tight by filing the edges and to make sure that it fits perfectly, and it's actually taking the shape of the cowl as it sits here even. I use lots of clamps to hold it in place so I can make sure all my joints are really tight, because we want these joints as tight as possible and to hold its shape while we tack. That way it doesn't warp when we're finished. And to get that, I hand filed, and I had actually hammered some of the edge where I was cutting with the snips to make sure that it's nice and flat and smooth. So it seems like it's fitting very well right now. And when I start to tack, I'm gonna start in the middle, and I'm gonna tack about every 3/4 of an inch, and I'll work my way out and work my way around completely. One mistake I've seen a lot of people do is they'll tack, and again, this is something that's kind of unique to me that I've figured out on my own, but if I start tacking different places around, it creates stresses in it, which will wind up warping my piece. So if I start in the middle and work my way out, I can actually use that to help tighten my joints. And since we scribed it when everything was completely stress-free and relaxed, that scribe mark is really where the metal should be when we wind up. So by starting in the middle, each tack you put in it actually will tighten your joint. It shrinks the metal, so every tack I put in it, it tries to close that gap more and more as you work your way around. So if I start here and then I jump here and around, it starts moving things all over the place, and we don't want that. So I will start in the middle and work my way around. One thing when doing light sheet metal is sharpening your tungsten properly. When you grind a tungsten, it should be ground towards the tip. So when you go into your wheel, you want it grinding away from the tip. But also there's all the little marks in it from the grain of the stone as it's grinding it. The electrons actually follow those lines so that it puts a nice sharp point to your arc, which really helps, especially on thin sheet metal. So now we'll start tacking. One thing that happens while you're tacking is that a lot of times it'll bow up, and like I say, it pulls together. So you want to take, as you go, and hammer your tacks out flat so that it maintains that original shape that you held. And what you're doing, if you hammer this tack, you're actually stretching, you're planishing that tack. So you're stretching it back out to where it used to be. So if you do this as you go, it maintains the flatness, and also it maintains your gap. So now I have tacked the piece in about every 3/4 of an inch. I have a tack all the way around. I hammered it flat with a hammer and dolly to make sure that I don't have any high and low spots. You want the top, top of the two pieces flush with each other before you start welding. Also, I ground off just the high spots of the tacks. It just helps later on. And I used some Scotch. You can use Scotch-Brite or sandpaper and actually clean the weld so that it gets rid of the coloration on it, which is oxidation, which can also contaminate. Just makes it, if you always have it as clean as possible, you're gonna have less problems. Another thing is always keep your tungsten as sharp. If you dip it in the puddle by accident, stop right then and go sharpen it, because it's just gonna cause you more problems and actually probably cost you more time. So now we're ready to finish welding it out. And I know I've seen in a lot of instructional videos and books, people talk about skipping around and welding different sections, like 1-inch sections in different places to keep the heat down. Something that's my preference, and as time has gone on and I've gotten much better at what I do, I've learned if I start at one end and go all the way to the other without stopping, that it creates an even heat all the way across, and you're not skipping back and forth. And with that even heat, you get even shrinkage across the whole part. Then when you go back and you can planish your weld, then you're planishing it even. So basically that keeps everything even all the time. If you skip around, you shrink this area, and then you shrink this area, and you come back beside this one and shrink it, but it doesn't shrink the same because this one's holding it back from shrinking the same. So then you wind up with a wavy warpage throughout the whole thing, and you have to work that out later, which is, to me, is a little bit harder. So I like to start at one end and just go to the other. I'm using a 035 filler wire. It's pretty thin. And you don't need a lot. If you have this tight joint, you can almost fuse it, but if you fuse it, you'll wind up with some contamination in it. So you need that filler. All right, so I've made this pass. I actually made it all in one shot. I didn't stop any. And you can see how it's really the heat marks on either side. It's perfectly even all the way across. And that's important. I don't have waving this way. I actually have a slight crown this way, which is easy to take out by planishing it out later. And also by it crowning this way, I can easily sand my weld and take that off and then planish it back down flat. But it's a nice even heat across, so it has shrunk the same all the way across, so it doesn't really warp up your piece as bad. So it came out very well. Now I'll finish out the rest of the welds and sand, planish, and it'll be ready to put back on the car. Now that I've welded it out completely, I need to cut the top of the weld off, and to do that I'm using a 3-inch disc on a right angle die grinder. It's important when you're sanding something like this to use a good sharp disc. If it's dull, then it will actually heat the material up. It can cause warpage. So you want a good coarse cut first, and then you can step back and use finer ones for finer finish. But I think I'm using a 36 grit to start, and that'll cut the top of that weld off so that we can planish it out back flat. So. As you can see, there's some high and low spots, and we'll leave the low spots. And as we start planishing, they'll eventually go away, and if there's any more weld material, we can come back and sand some more. But that's how we wound up getting it completely flat. So my next step is to planish out the weld. I've now cut the top off, and using a flat toe dolly and an almost flat hammer face hammer. It's got just a slight crown in it. I actually have a series of different hammers with different radiuses to the face. But, I have one that's completely flat, but since we're working on a completely flat piece, I don't want the two pieces being completely flat. I need just a little bit of crown in my top hammer so that it actually will planish. So I have some crown in it this way, so I'm gonna put my dolly underneath, which is flat, and then I'm gonna hammer that crown out of it. And that's looking better. What that does is it actually stretches the metal at the weld. The weld metal is actually annealed, so it's softer. The filler metal we're putting in there is a little bit harder than the base metals, but it's also annealed. So I think it pretty much evens itself out. But what happens was when we welded it, it shrunk. So now we're actually stretching it back out to where it should have been originally. That's why we maintained that really tight gap. It shrunk, and then we're stretching it back out, so it should go back to its normal state. And that's the point of how the steps we took to get to this point. So now we'll finish cutting the welds and planishing out the piece. So here we have our finished cowl panel. So basically we took and cut out the old vent, put a piece behind it, scribed it, cut it out to exact so we would have a nice tight fit. Then we tacked all the way around progressively and came back and welded it and basically ground the weld and planished it so it's now perfectly flat and it's ready for paint. If you want to find out more information about Jimmy and myself, go to jimmyshine.com. You can see all the cool stuff we're working on. If you want to find out more about the Miller Syncrowave 210 and Miller, go to millerwelds.com.